Okay, so let's fiddle through 5.1 number 9 a little bit. So first things first, I'm supposed to consider that if I have a solution of this thing, I can go get another one, basically. So I've got P and Q that are continuous, and Y is a solution of this differential equation. That means specifically that this is true, right? And that this is always true. So this set of functions added together is identically 0, which is what it means to solve a differential equation. Then I have this function capital P is the antiderivative of little p, so I wrote that down. I'm looking at this part B thing, and I'm saying, okay, if y2 satisfies this, so I know this is true, right? This thing on the left is this thing on the right. I did a little algebra fiddling around with that earlier when I was talking about this problem with somebody. And then I think I know, like, the goal that I'm trying to do, that I'm trying to see here, is I'm supposed to show that y2 satisfies this initial differential equation if it satisfies this differential equation. So what I'm going to do is I'm going to need to sub y2 into my differential equation, because that's how you check if something solves, or how you demonstrate that something solves. So my goal here is going to be to put y2 into this differential equation, essentially. So I'm pretty confident that I can put y2 in for y really easily. I know what y2 is, it's just y2, so I'm just going to put it in there. I'm considering y2 prime. Well, y2 prime is also something. I know it from this equation B, right? So that's this. I could substitute this in for y2 prime, and then I would have it in terms of only y2 and y1. This y2 double prime is really my problem, so I'm going to go on a little side quest to find that thing. So the way I'm going to do that is I'm going to take my equation in part B, and I'm going to hit it with d dt. So I'm going to essentially just do, I'm going to kind of start with equation B, right? And I'm going to hit this with d dt. Now I know B is satisfied by y2, because that's my assumption about y2 is that it satisfies this thing. So when I do this, I'm going to have to use the product rule on this thing. So I got the derivative of the first thing times the second, plus the first thing times the derivative of the second. So all of this stuff is d dt of this first term here. So that's the derivative with respect to time of y1, y2 prime. Okay, to that I need to subtract, and the thing I need to subtract is going to be the derivative of this thing. So that's going to be y1 double prime, y2, so that's derivative of the first times the second. Then I need plus the first times the derivative of the second, so that's y1 prime, y2 prime. Oh, and I'm going to be able to make my life a little easier. I'm not even going to have to have solved here. I think I can pull a slick trick here. Okay, so that's my derivative of this second piece. I might still have to solve, I'm not sure. We'll see. Okay, so that's d dt applied to y1 prime y2, right? And then on the other side, I'm going to have equals, and I need to, I guess I'm writing d dt, but this functions in terms of x. Crap, sorry guys. So those should be x's. Okay, so on the other side here, I need the derivative of k e to the minus p of x. So that's going to be k e to the minus p of x, right? Because when you differentiate e to stuff, you get this e to the stuff, and then you need times the derivative with respect to x of minus p of x, right? Which I know this. So because capital P was an antiderivative of little p, I know that this whole business is going to simplify. Actually, do a slightly different thing with that. I'm just going to scoot that up, turn it green, because I'm going to think that when I differentiate this, right, I'm going to get minus little p of x. And so this piece is that guy. So this whole left-hand side is the derivative, or sorry, right-hand side is the derivative of this object here. All right, so I got all this stuff. And now I'm going to think to myself, all right, self, I really need to plug this in here for y2 double prime. And that's going to suck. I'm hoping to see something canceled, but I don't right away. All right, so guess we're going to shove it in there. So I need to find y2 double prime. So the way to find y2 double prime here is we're just going to solve, right? So let's see, I've got just the one y2 double prime, so I'm going to leave that guy by itself. So I'm going to have y1 y2 double prime is going to equal, and on the other side I need everything else. So I've got k e to the minus p of x times my, I guess I have minus k p of x times little p of x. And then I have a plus y1 double prime y2 plus y1 prime y2 prime. That's all this piece. And then I'm going to have minus that thing. So I've got minus y1 prime y2 prime. Okay. Let's see. All right. Next thing next, I'm going to need to divide by y1 here. So I'm going to get y2 double prime is all this crap over y1. So I've got minus k e to the minus p of x times little p of x over y1 plus y1 double prime y2 over y1 plus y1 prime y2 prime over y1 minus y1 prime y2 prime all over y1. All right, now I'm supposed to check and see if this satisfies my differential equation, right? So I'm just going to take this stuff, and I'm just going to do a whole bunch of copy and pasting here. So I've got this stuff, that whole thing, all of this stuff here is y2 double prime. So I went and got that. And then I have plus, and if I look at my differential equation, I'm supposed to have p of x. So I'm going to have p of x. And then right here should be y2 prime, right? Because I'm trying to check and see if this is satisfied. So I'm going to take y2 prime from right here. I don't think I got all of that. I'm going to take y2 prime from right here. Came out with a little extra. Okay, so we don't need our pink thing here. We do need one on the top. So all this stuff is y2 prime. Oops. And really I should have parens around that whole thing. And then lastly, I need q of x, y2. And basically, I'm just wondering what this is equal to. Okay, so let's just see what it's equal to. Oh, that's wild. See this thing? We've got a minus k e to the capital P times little p. If I multiplied this in here, right, I'd have exactly that same thing. I've got a k e to the capital P, a little p, and over y1. Okay, so this term here cancels with this term here. And then I'm thinking, Okay. What else have I got here? Feels like I've got some extra stuff going on. Huh. Okay, so what's going through my head right now? I'm looking at this y1 double prime, and it's got a y2 over y1 attached to it. And then I'm noticing here I've got a p of x, and here I've got a y2 over y1 attached to this thing. So I'm thinking to myself, hey, wait a second. I thought this sucker solved. Right? y1 solved my differential equation, so I was kind of expecting to someplace in here see one of these guys. Now, I'm a little bit at a loss as to where the heck my q went. You guys see that? But I see at least these two pieces in there. So I'm going to group this thing up and see what I can do. So let me think about grouping this guy up a little bit. So I'm going to take this term. So I've got a y1 double prime times y2 over y1. And then, so that accounts for this term. Oops. Maybe I should do this. That accounts for term 1 there. Then I've got this guy. So I've got a plus p of x times a y1 prime y2 over y1. Okay, so that's item 2. And then otherwise I've got this stuff. You guys see that? I've got this thing together. So then I've got items 3 and 4 and 5 are going to be, I've got a plus y1 prime over y1 with a y2 prime. Oh! You guys see that? Those just cancel. Did I do something wrong there? You guys see that? When I did this part, when I did these derivatives, I just didn't even notice this first term here out of this one and the second term out of that one. They're just the same. I should have canceled those a long time ago. Crazy. Let me double check that those actually came from the right place. So those should have been the derivative of the first here times the second. Yep, that checks out. And then the first here times the derivative of the second there. Oh, yep, those are opposites. Should have canceled those a bit ago. Yeah, that's what happens when you got lots of symbols kicking around. Okay, so those two guys cancel, which means that, oh yeah, right here I wrote them one after the other. Good work, Joe. Solid dum-dumming. Those two terms should have canceled, which means these two terms are gone. Okay, so that makes me feel a little better. So I got term 1 there, I got term 2 here. This term does not actually exist, and then I have q of x, y2 here. Okay. Oh. So now I'm noticing, like, I'm wondering what this is equal to, right? So let me think here. I'm gonna factor a 1 over y1 out of all this thing. So this was term 3. Right, so out of all this, I'm gonna factor a 1 over y1. Right? So out of this junk, I'm gonna have 1 over y1 times, oh, and look, there's a y2 in everything as well. You guys see that? So I'm going to factor out a y1 on the bottom and a y2 on the top. So I've got y2 over y1 that I'm factoring out. So I'll have y1 double prime plus p of x y1 prime plus, and then the y2's out of here, and I'm supposed to factor out a 1 over y1, which means I'm thinking about this as multiplied by 1. Oops, let me do that in a different color. So I'm thinking I'm just going to multiply by 1 here. So I'm going to multiply by y1 over y1. This one's going to get factored out. That's going to get factored out. That's going to leave me with a plus q of x y1. And then because y1 solves my differential equation, I know this stuff is identically 0. Right? That stuff's all 0. And so this whole thing is 0. Check, done, solves. Alright, and then if we want to see that it's a fundamental set of solutions, you can see that this is the Wronskian here. I'll leave that to you guys. And then we conclude from part A, this thing, that's just solving this guy as a first order linear non-homogeneous differential equation using variation of parameters. You guys also got that. I think most of the trick is just in this algebra here. So, gist of it was, we solved this for y2 prime, and then we differentiated and plugged in for y2 double prime, y2 prime, and y2. And then we just noticed that a whole bunch of stuff cancels. And so it is in fact the case that if I have y1 that solves this thing, I can get another one by solving this other differential equation, which is nice because this is first order and I can solve those.